So I'm going to start just reviewing the triangles again, because you might be a little rusty. Some kids like the triangles. Let's get into it. Find two solutions to this equation. Sine of x equals square root of 2 over 2. Now, as soon as I see the square root of 2, clearly we're on the 45, 45, 90. The key is which quadrants. All right, so remember, it gives you the little hint. Use your all students take calculus. And remember, that's telling you where the functions are positive. Everything's positive in 1, sine is positive in 2, tan in 3, cos in 4. Now, we have, of course, sine being positive. So sine's positive in 1 and, of course, 2. So that's where I'm going to draw. And we know our 45, 45, 90 because of that square root of 2. So 45, 1, root 2. It's great. I feel like I'm teaching geometry. Doesn't that just bring happiness to your heart? Yeah. Like it? This is very convincing. Of course, if you do sine, you're opposite over hypotenuse, and you rationalize it out, you get your square root of 2 over 2. Now, answers. Of course, we have two triangles, you have two answers. Clearly, one of your answers in quadrant 1 is just your plain old boring 45 degrees. And you just have to, of course, read directions close today. They might ask you for degrees. This doesn't say, I'm just going to roll with it. They might ask you for radians, so just read closely. Now, second answer, of course, we have to measure from 0 around. You are 45 short of 180. So what's your second answer? 135. Okay. And those are our two solutions, and we are done. Can't beat that. Find two solution, tan of x equals 0. Well, as soon as I see the 0, I know I cannot make a triangle with the opposite over adjacent. I can't have a triangle being 0. So, of course, I'm thinking about our quadrantal angles, our points. So let's get those all drawn. And just to review, because of course this is coming into play if I'm going to switch and use unit circle, which I might on some problems today. Remember, your ordered pairs are cosine is the x coordinate, sine is the y coordinate. We need tan. You know your identities. How does tan relate to cosine and sine? Sine divided by cos. So I'm just going to go around the 4 points and do sine over cos and see which turns out to equal 0. So if I do sine over cos, well, I like that. There's the 0. That's a win. If I do sine over cos, undefined, not it. Sine over cos. And of course, if I do sine over cos, that's undefined, not it. So specifically, what are the two angles that correspond to those points? The left point, let's start on the left. Left point is 180. Right point would be 0. And it didn't say radians or anything, so I just left them in degrees. So this is kind of the preview of what we're going to be doing, solving equations. But like I said, you guys have, I'm clicking clear to the end here just for a second, because you guys have your unit circle. Could have I gotten that information off my unit circle? Yes. Do I care how you do it today? I do not. I sure do not. Okay. So of course we had that 45 answer, that square root of 2 over 2. And we had our 135 answer. You are welcome to use your unit circle, because clearly you've proved to me we all know the unit circle and how to fill it in on our last chapter test. So now it's one of those tools we just get to use. So some of you, and it just depends. I think tan's maybe a little tough to do off the circle. So it just depends. You could, if I just got my unit circle out, look at where you have the y value root 2 over 2 and write down those angles, and I could have been done in like, I don't know, 3 seconds. Well, maybe longer. It takes me a little to click to the end. Tan, of course, you're going to have to do the division of the sine and cosine and figure out which point or points your answer is going to be. So I'm going to kind of mix and match today. I'm probably mostly going to use the unit circle, so you're going to see me flipping to the end a lot. You can use it too. Tan, I might do a little bit of triangle work. All right, read our directions close. Find the solutions in the interval 0 to 360. So they want them in degrees. Now, I'm just going to go unit circle style here. Why do more work if we don't have to? So click to unit circle. Well, I'm going to click to it. You've got yours. And we're looking for sine being positive 1/2. Sine positive 1/2. What are the two answers where sine is positive 1/2? 30. And, of course, 150. why do any more work than that? I'm going to click clear back to the front and write 30 and 150.
So why do we do all that complicated stuff the days before?
We just got to show multiple ways to do things, you know. So you appreciate the ease of the unit circle. All right, cosine. Square root of 3 over 2. Click to the circle, right? I should have just left it up. Okay, square root of 3 over 2 for cosine. Remember, cos is the first coordinate. So here's a square root of 3 over 2 for the first coordinate. Where else do you see it?
Oh,
So we've got 330. Square root of 3 over 2. I kind of wrote over it right there. So my two answers, of course, 30 degrees, 330. It's going to take me longer to flip back and forth, I think. I guess I could make it look nice. I'll put x equals on just so it seems a little fancier. There we go. All right, tan. Now, tan's the only one I would say I don't necessarily love from the circle. I'll use the circle a little bit because, of course, you have sine and cosine. So I'm just thinking about the circle right now. Of course, all students take calculus. Well, I can't think about being in 1 or 3 because tan's positive there. So I'm going to be looking at this guy, at your 2 and 4. And of course, tangent, opposite, adjacent. That would be a 2. So can you figure it out if you do sine over cos around the circle? Sure. But sometimes I think tan's easier almost to do the triangles. Up to you, I don't care. So what's your first answer?
120.
120. And you're welcome to get that from the circle. Now, I'm too lazy to even label all the sides on the second triangle. I care about the 60, of course. If you measure from 0 clear around, you're 60 short of a full circle. So your second answer is 300. Elliot. Oh, I'll get that from you at the end, okay? Yeah, no worries. So any questions on those? Okay. And again, I don't care if you're using the unit circle or the triangle, as long as you get the right answers. Okay, let's live on the edge. We're using 0 to 2 pi, so radians, big bluff. Ooh, okay. And secant. I don't care. Secant doesn't freak me out. We like to work in sine, cos, and tan, though, our main 3. So if you know secant, of course, you know cos. What's cosine? 1/2. All right, don't make me flip back to the unit circle. It's getting irritating. Just take a look at it and find where cosine equals 1/2. In radians, what do you got? Pi over 3, there's 1. Where's the other one?
It's 300 degrees.
300 degrees, but they want radians. Got it.
I got there.
All right. See, doesn't this seem like ridiculously easy after yesterday?
Yeah.
Whew, like it. Okay, I really only have just one little twist at the end, and it's easy, I think. Cos x equals root 2 over 2. Look at the triangle. Give me them in radians.
Pi over 4.
Pi over 4. Where else do you see square root of 2 over 2?
7 pi over 4.
7 pi over 4.
I got there pretty
Any questions on those? I'm happy to click to the circle if you need. All right. Fun, fun, fun. Now, little big directions, so we got to talk about that. And of course, you got a little extra work. You got to solve for sine. Big deal. I'm going to add 1 and divide off 2. Okay. 2 things we have to talk about. 1, directions. It doesn't specify degrees or radians. You're just magically supposed to assume, if it doesn't tell you, I want the answers in radians.
What?
Yep. So let's start with that. So look on your unit circle. Where is sine 1/2? In radians.
Pi over 6.
Pi over 6. Where else?
30.
Where else is sine 1/2? 5 pi over 6. Now notice I kind of separated these out. I'm getting fancy. There's a reason.
Oh my gosh.
Here's the other thing. Don't circle your answers yet.
One of them works. One of them doesn't.
Just wait. This is easy. Just wait for it. Wait for it. Now, we need to talk about, or flash it back to coterminal angles. Hopefully that vocab rings a bell to you. Here's the thing. Notice in the directions, you are not restricted from 0 to 2 pi, aka 1 circle. So I could add 2 pi to that and land at the same spot. I could add 2 pi, I could do it all day long. It'd be super duper boring. Same thing here. You could go around the circle an extra lap and add 2 pi, add 2 pi, add 2 pi. So we have to account for our coterminal answers because we're not limited to one circle. So we are going to add multiples of 2 pi. That's an N. I'm just going to put a little note. That is for your coterminals. Yep, we could go 1 circle, 2 circle, 3 circles, 4 circles. I could go all day long. Nobody wants to see that. So if it doesn't restrict you to 0 to 2 pi or 0 to 360, you have to add that on for all the possible coterminal solutions. Okay, here we go. Let's solve for cotan x. I'm going to add 1 divide by 3. And start with that. What gets rid of, of course, squaring? Square rooting. Now, I don't like that it's cotan, but whatever. I'll deal with that in a minute. Square root of 1, that's cool. Square root of 3. And here's where it's going to get fun. You square rooted, what do you need in front?
Oh my gosh.
Okay. Now, I don't like to work in cotan, especially if you're trying to use your unit circle. I would think of that maybe tan. I'm going to do my plus minus. Now, you're welcome to go around a unit circle and find a 4 angles. 4. Because of plus or minus. I know I'm super dramatic about it. Where you're opposite adjacent. Now, I'm going to kind of, draw you a little picture. So, of course, if you're in quadrant 1, I'm going to start in 1. TOA, tangent, opposite adjacent. So 60 degrees. That's, of course, the key. So what is 60 degrees in radians? Pi over 3. And gross, we need the coterminals. This one's going to make my arm hurt. Now, plus or minus, you can be in all 4 quadrants. Because if I do tangent over here, that works also. Measure from 0, so you're at 120. Well, what's 120 in radians? 2 pi over 3. And your coterminals, probably seeing a pattern here, right? What would be your answer? I'm not doing all those sides. We know 60, that's what we're after. What's your answer in the 3rd quadrant first in degrees? 240. What is that in radians? Got it.
It's just adding 2. So why are we writing all of them?
Okay. Final answer in quadrant 4.
I think it's 2.
What would that be in degrees first? 4th quadrant. What is your answer in degrees?
330.
Nope.
I mean 300.
300. We're 60 short of the full circle.
Dude, I don't know.
What's 300 in radians? And we need our coterminals. Ay, that almost made my arm hurt. Now, because you kids understand math, okay, I find that, and you probably do too, obnoxious to write out all 4 answers. So of course I've got a pro tip, I've got a hack for you. I can cut this down to half the amount, okay? Here we go. Now, first, why are there 4 answers? The plus or minus, because tan's positive in 2 quadrants, negative in 2 quadrants. That put me in all 4. I am too lazy to write out all 4. So here's how I'm going to roll. I start in quadrant 1, of course. So I start with, you see I picked up green. I start with my first answer, the 60 degrees, the pi over 3. Now, work smarter, not harder. I'm not going to add a full circle to that. I'm going to do half a circle. What's half a circle? Pi. I'm going to add multiples of pi n. Here's why. If I add half a circle to this, I'm in 3. A half circle, 1. Half circle, 3. That gives you all the answers for 1 and 3. Now, of course, I need the quadrants 2 and 4. Okay, so I take my answer in 2. I'm not going to reinvent the wheel. I'm just going to copy it. But instead, I keep adding a full circle to come all the way around. I'm going to do a half circle. That will get you into quadrant 4. Back to 2. Back to 4. Now, do I care which way you roll? If you want to do all four with the full circle or shortcut, I'd probably go shortcut. I don't care what you do, but long as you can generate the answers. It doesn't matter to me what style you put them in. So one little trick of the day, I don't think that's bad compared to, though, still easier than yesterday, right? Right, I hope. Okay, now here you are in a factored form. I know get instinct, kids always want to distribute. And I'm like, don't distribute. You're factored, you're set to 0, set each one to 0. So I'm going to do cos to x to 0. We can get that straight off our unit circle. And of course, most of you probably just went ahead and added 1 over. Now again, let's not get crazy here. Pull out your unit circle. Where does cosine equal 0? 90, we want radians, so I'm going to go pi over 2. Where else? 3 pi over 2, yes. Love it. And we need the coterminals. Yes. Or, always an or, right? I'll take those. I still have to do my cos of x equals 1, I'm aware. But, could have you shortcutted this? Could have I just done 90 degrees and added a half circle to it to get to 270? Half circle, half circle, half circle? Sure. So you could have done pi over 2 plus pi n and eliminated the bottom. Do I care what style you do? Of course I do not. All right, cos of x equals 1. Where does cos of x equal 1? So at 0 or 2 pi, I'm just going to go 0. And we have to add the multiples, our coterminals. Now, you can leave that if you want, but do we really need the 0 plus? Again, I won't mark it off if you have the 0 on there because I know that's where you're starting, okay? So again, gut instinct, everybody wants to distribute cos through, and I'm like, don't do it, it's factored. Leave it. All right, let's do D. Now, this one is not factored. I can't get crazy, do anything wild here. You might, I always have kids that maybe look at cos squared and be like, let's make it 1 minus sine squared. I'm like, wait. They need to have different trig functions in it. So just leave it. You have a trinomial. Let's factor our trinomial. Now we have small numbers. I don't have to do some crazy long factoring process. We can figure it out to get 2 cos squared. Of course, 2 cos and cos. Now our last term's 3. 3 is prime. You know I love a good prime number. Only way we can get 3, 1, and 3. So we have to kind of do a little guess and check FOIL to figure out, do we want the 3 first or the 3 last? Last. Pluses, minuses, what do you got for signs? Minus. Because I'm going to have minus 6 minus 1 combines, of course, to the minus 3, or sorry, minus 7 in the middle, and then your positive 3. Set each factor to 0. Probably most of you are going to eliminate that line I just wrote and just mentally solve these and make it 1/2. I would 2 personally and 3. All right, 1/2. We've got that all over our unit circle. Well, I shouldn't say all over. That's dramatic. We do have where cos is 1/2 on our unit circle in 2 spots. Where does cos equal 1/2? 60 degrees. I'm going radians, and I'm including the coterminals. Where else does cos equal positive 1/2? 5 pi over 3 at 300, and the coterminals. Okay, let's talk about this cos of 3. First off, I mean, you know the answer to this. Do you see just plain 3, not square root of 3, just a plain 3 anywhere on your unit circle?
No.
So I'm like, oh gosh, I gotta draw a triangle. But then I'm like, wait a minute. Geometry. Cosines, adjacent, hypotenuse. Can you make a triangle where the hypotenuse is smaller than the adjacent?
No, you can't.
So we're not going to get any solutions off of that one. We can't make a proportional triangle. There's the fancy phrase. Any questions on that guy? All right. Home stretch, everybody. Home stretch. I know you love it when I say that. Okay. What are you thinking on this one? Factor, one of my favorite F words in math. Let's factor. What are you factoring out? Cos. You might have a different favorite F word in math. Okay, so we're going to set each factor to 0. Now, cos theta equals 0. That's nice. We can find that super quick on our sheet. We'll do it in a sec. This kind of weirds me out, but we'll get into it. All right, let's start with the first one. Where does cosine equal 0? What?
Over 2.
Pi over 2. Where else does it equal 0? 3 pi over 2. So let's be smart here. I don't want to write them both if I don't have to. If I want to toggle between pi over 2 and 3 pi over 2, I'm not going to add 2 pi n. I'm going to add pi n. And I'm just going to make a little asterisk note that that will include or get you to your 3 pi over 2. Okay. Let's talk about that for a second. Now, this is a little preview of what we're going to see tomorrow. Get ready for it. This isn't on today's homework, but I'm previewing for tomorrow because you know I love it. First off, is negative 2/5 anywhere in the unit circle? Nada. But here we go. I'm kind of going out of order. I'm going to do these next. Approximate, because they're going to have you do some approximating tomorrow, which is not a big deal. You can use your calculator, of course. Solve the following rounded to decimal places. So I'm going to pull up my calculator. We need our mode on radians because it doesn't say, so we assume radians. Thanks for telling me. Oh boy. Now, from your glory days of geometry, do you remember what to hit in your calculator to get an angle? You don't just hit cos, you do inverse. Yeah. So hit cos inverse, second cos. It'll pull up the parenthesis. So I'm going to punch that in, second cos, 0.65. 5.
It's about 80.
So it says rounded to decimals. Let's go 0.86 with it. So our answer is 0.86 radians. And then let's do tan equals 2. So I'm going to do tan inverse. So let's go 1 point, I guess 1, 1. So 1.11 radians. Now remember, when we talk about radians, of course, we have pi all the time. Pi is just a number, 3.14 approximately. So when we do like pi over 2, it's about 1.57 if you do 3.14 over 2. Now, I'm going to back up the truck, okay, because I haven't forgotten about this little funzo. So first thing I'm going to do in my calculator, I'm going to do sine inverse of negative 2/5. And I don't remember what the decimal is. I don't know.
Thank you for me. Didn't want to put it in.
So about negative 0.412. Should we just round it?
I was thinking do the hundreds.
What do you want to go to? 0.41?
1. No, just go to 1.
1? Okay. Now, that's not my total final answer though. Yeah, almost, kind of, sort of. Because remember, we should get 2 solutions per equation. So I'm thinking, of course, about this. And I'm going triangle style because unit circle doesn't have 2/5 on it. Negative 2/5. Unit circle does not have 2/5 on it, so I've got to think about all students take calculus. I got to kind of go old school on this one. Now, sine negative. So that eliminates these guys. So our angles would be in the bottom half here in quadrants 3 and of course 4. Now, you've got negative 0.41. So think about this. If we rotate from 0, that's going to be this guy. That's a point in front of it. I didn't put the negative on because the negative, of course, just affects your direction you rotate on the circle. I care about the 0.41. So to list my 2 answers, I'm going to work off of this one first. Now, you could measure from 0 all the way around. Nobody says I have to give all my answers positive. Nowhere does that say that in these directions. So I'm just going to say, hey, I got to add my coterminals to this. So that's going to give you this answer. because I rotated down 0.41, the coterminals. We still need the other one, the quadrant 3 answer. So I'm going to measure from 0 around. Well, you are 0.41 past 180 or past pi. So in my calculator, well, maybe mental math, I'm going to do pi plus 0.41. Can you mentally add those up? 3.5, and then our coterminals. So this is a little preview of some of the problems you're going to see tomorrow. We're going to have to do some approximating and go old school to get our answers. That's why I brought back the triangles to you today. I know most of you are going to use the unit circle for the homework. I would too, okay? But tomorrow we're going to see there's some cases where I have to go on the triangle because it's not on the unit circle. So just, you know, always thinking ahead, kids, always thinking ahead. So any questions on that guy? We'll see some more.